Solve the system of equations below by graphing and write the solution as an ordered pair. For credit, the ordered pair must be correct and both lines must be drawn correctly on the graph. Okay, so basically we got two equations, don't we? Which is gonna produce two lines. You know, one of the lines is gonna be like this. The other line is gonna be like this. And then where they intersect is gonna be the answer to the whole thing, to the whole system. So we're gonna graph two lines. Each of those equations produces a line. We're gonna graph two lines and find their point of intersection. And that point of intersection we'll write in here as an ordered point, whatever the X is and the Y, like maybe 2, 1 or whatever. This is 1 over 2 of 1 that I just made up. We're gonna write that in as our answer when we find where they intersect. That's the plan. All right, let's take the top equation. Bring it over here. This one's y equals minus 2x plus 2. Now that one already has y alone, so he's easy. I'll just write that y alone. Y is already alone. So then you know what to do, right? We start with that as our vertical y-intercept. So that's going to be right here at up 2. Good there, right? Because this is the y-axis and the x-axis. And then this right here, minus 2, you put this over 1, and this is rise over run. The fraction next to x, and if it's not a fraction, if it's just a whole number, put it over 1 because that doesn't change anything, right? Negative 2 divided by 1 is still just negative 2. And now we have a rise and a run. We can get our second point. How do you get your second point? You rise negative 2. That'd be down 1, 2. Down 2, that's my rise. Negative 2, and run, positive 1. Positive 1, run. And there's my second dial. Are we good there? So I went down 2 over 1. So my first point is the number off to the right. That's your starting point, your vertical y-intercept. That's on, and then from there you do the rise over run, the fraction next to x, down 2 over 1. And then we connect those two dots to form our line. So let's do that.
Charlie.
And just like that, there we go. Okay, so now we got that line. And now for the second line, I'll grab the second equation over here. And this one's going to be y. No, it's not y equals, is it? It's 4x plus 8y equals negative 8. Okay, so on this one, we are, so this one we have to get y alone first because we didn't already have y alone. The last one we had y already alone. So step one, get y alone. So to get y alone, we got to do a little bit of work. So I got to subtract 4x from both sides, like that. Boom, boom. And we get 8y is minus 4x minus 8. And then divide by 8. Remember when we divide all three, all the way across. Equal treatment. Equal treatment. Everybody gets the same treatment, right? When we have an equation, they're equal. They're in balance. What we do to one part, we got to do to all the parts, all three. So y equals. Now, we got to reduce these. How do you reduce that fraction? You know how to reduce that. You just divide, or how about, yeah, just divide top and bottom by 4. And you get minus 1x over 2. And this is just minus 1. 8 divided by 8 is just 1. How are we doing there? I reduced that fraction. I divided top and bottom by 4. 4 divided by 4 on the top is 1. 8 divided by 4 on the bottom is 2. And don't forget the negative sign, which is still there. All right, now we're ready to graph that line. So how do we graph that line? Well, you know, you start with a number out here, right? That's your starting point. That's the vertical y-intercept, huh? Negative 1. That's going to be right there. Okay, and then this right here is rise over run. So I'm going to go down 1 and over 2. Boom, boom, that. So down 1, that's the rise, and over 2, that's the run. So again, we get y alone. Once you get y alone, the number off to the right is your starting point. It's your vertical y-intercept right there. It's where the graph goes through the y-axis. And then the other fraction, the fraction next to x, is your slope, rise over run, down 1 over 2. It hits right there. And then we connect those 2 dots with a straight line. So I'll do that. Okay, keep it going the other way. Okay. And there's that line. Okay, so we graph the 2 lines. And here, put the arrows on this one. Graph the 2 lines, and then our answer. So first off, they want you to graph both lines. And then the final answer is where they intersect. Well, they intersect right there. And what are the coordinates at that point? That's over 2, down 2. Over 2. And you got to put parentheses around that, like this. Over 2, down 2. That's the point of intersection between the 2 lines. The 2 lines intersect at the point over 2, down 2. That's the x and the y. Over 2, down 2. That's the solution to the whole system. So what did we do? We took both lines, graphed them both, found out where they intersected, and that intersection point is the solution to both equations. Now, why do I keep saying that? We're done at this point. We're really officially done, but I want to prove something to you. I want to show you. Remember the points on any line make the equation, that line's equation, true. So therefore, notice this point here and this point here are on the first line. So that means if I plugged either one of those in, the x and the y, they would make that equation true. Or the same thing goes for these 2 points that are on the second line. If I plug them into the second equation, they'd make that one true. So this point right here, the intersection point, is on both lines. So that means he makes both equations true at the same time because he's on both lines. He's the intersection. He's going to make both true. That's why he's the solution. Let's prove it. Is that really true? I'm claiming it. Let's see it. If I come up here, just 1 second. Let me finish this first, okay? So if you come on up here and you plug in, what I'm saying is you plug in the x and the y. If you plug in x is 2 and y is -2, and same thing here, x is 2 and y is -2 there, it's going to make them both true. Let's see it. This will be -2. This is just for fun, not required at all. It's fun. I hope you're having fun. I'm not sure this is fun, Mr. Aaron. All right, so plugging in x and y. So we get -2 equals, what is this? -4 plus 2. -2 equals -2, right? -4 plus 2 is -2. See how it made it true? How about the second equation? Does it really make the second equation true? If you grab, I'm running out of colors here. If you grab the second equation, maybe I'll just bring it right down here. I plugged in 2 right there. I get 4 times 2 plus, and this is what, 8? 8 times -2. Does that really equal -8? That's 8 minus 16, right? 4 times 2 is 8. 8 times -2 is -16. Does that equal -8? 8 take away 16 is -8 equals -8. Beautiful. Look at that. See how 2, -2, 2 for x, 2 plugged in for x there, 2 plugged in for x there, and -2 plugged in for y there and there, made both equations true. -2 equals -2, which it certainly does, and -8 equals -8. It made both equations true at the same time, didn't it? Why did it do that? Because it's the one point that is on both lines. Remember, if you're on a line, you make the equation true. So if you're on both lines, you make both equations true. Now let me erase all this mess because it just kind of messes everything up. You don't need to do this, not required, but I just want to show you what it is we're really doing. We're finding what makes both equations true by finding the point of intersection. And that's the answer to the system, is this point of intersection. Questions I can answer now.
Can I share my screen? Because I'm not really sure, because I got the lines right, but I'm not.
Sure.
Okay.
Sure. Let me, go ahead and share your screen.
Okay, so I got this right, but my
no. See the yellow check mark? That means it's partly wrong.
it's partly wrong.
Yeah. Okay, I can see the part that's wrong. Your first line up here,
Mm-hmm.
first equation, this one. Tell me your thoughts on that.
So my y-intercept would be 1.
Perfect. Right here.
So there's right there. And then my external intercept would just be 2, right?
No.
So
That's not an
0.
x-intercept. That's a slope, right?
Oh, that's right. So it's 2/1.
Yes.
So it would be up
It's 2
to
over 1. Oh, right.
up to over 1.
Perfect. There should be your second point. So why don't you clear what you got?
Oh, I don't know what I did.
Okay.
I have no idea what I did.
That's okay.
And let me go back real quick. One second, Mr. Heron.